Section 3.2 is on page 92, talks about compartmental analysis. We're going to focus on mixture specifically. The rate of change of a substance. The substance could be salt, could be acid, could be sugar, depending on what it is, in a tank, is dy dt, is equal to the rate at which y flows in. So y, how much of that salt is coming in, how much of that acid is coming in, how much of that alcohol is coming out, minus the rate at which it floats out. Excuse me. And if I start reading the problem number 2 on page 100, I'll say, all right, a brine solution of salt. A brine is a salty, it's really a purplish color liquid. It's very salty. So a brine solution of salt flows at a constant rate of 6 liters per minute into a tank. So I figure the rate N is 6 liters every 1 minute into a large tank that initially held 50 liters. The initial volume is 50 liters. Of brine solution, in which was dissolved half a kilogram of salt. If I let y equal the kilograms of salt in the mixture, then this would be y of 0. You could use any variable. You could use x of 0, whatever you like. Those are the initial amounts. And now let me see how this works. The rate in, we're coming at 6 liters per minute. The solution inside the tank is kept well stirred and flows out at the same rate. So rate out is also identical. That is 6 liters per minute. Alright. But that's the liquid. That's not the amount. If I write dy dt equals, if I say rate N, 6 liters per minute is not the rate N, that's the rate of liquid. I need to figure out how much of that is actually salt. So, and we're stirring this. All of these problems are under the assumption that we're stirring those well, in which the concentration is the same all throughout the medium. So it says, if the concentration of salt in brine entering the tank is 0.05 kilograms per liter. Do you see now I'm figuring out how the amount of salt that's entering the tank minus the rate out. And here we're letting out 6 liters per minute as well. So the volume is fixed. And what is the rate? Salt of brine. Okay. Determine the mass of salt in the tank at any given time t. You always have to do that. Let's see what the rate is. The concentration. Since I start with 50, I'm letting in 56 and out 6. The volume is 50 liters still. The amount of salt, didn't we say let that be y? So here's the deal. I have a mixture that contain half a kilogram of salt. By adding less concentrated or more concentrated mixture, I'm changing the concentration in there automatically. Meaning, the 0.05 and the 0.5 might throw you off. Let's say I have a cup of coffee, right? And in it I have 3 spoons of sugar. If I add any extra coffee that has less than a concentration of less than 3 spoons per cup, then that cup of coffee that I have is going to start becoming more bitter. And if I add any kind of coffee that has more than 3 spoons of sugar in a cup, then that's going to become sweeter. So basically, again, if I have a cup of coffee and I added sugar to it and it turned out to be too sweet, if I want to dilute it, I can't take the sugar out of it. What I could do, I could add pure coffee to it, and that will dilute it down to the desired, taste. Okay, so now, if I really simplify this a bit, those under each other, I'm looking at dy dt equals, and if I really write this, this is 6 times 5 over 100, 5 over 100 minus 3y divided by 2 over 25. So if I make them both over the same denominator, I could separate those. If I divide, let's see. If I divide this by 2 and this by 2, that's 50. I could reduce it more, but that's going to be 15 minus 3y, minus 6y over 50. There. I'm doing this because I want to separate those. And that is dy over 15 minus 6y equals dt over 50. And if I integrate, I'll get negative 1 over 6 natural log of 15 minus 6y equals 1 over 50t plus c, right? And natural log of 15 minus 6y equals negative, if I multiply by 6, you know what, I'll do it in 2 steps. So 15 minus 6y equals negative 3 over 25t plus 2 minus 50 floating around. And if I swap those, I'll get 15 minus e to the negative 3t over 25 plus c equals 6y. Keep in mind, if I divide by 1/6, this is divided by 3, that's 5 over 2 minus 1 over 6. Keep in mind this is e to the negative 3t over 25 times e to the c. Now I just need to find what this is, and that's where the initial condition comes in. I say y of 0, I put a 0 in there, that's going to be 5 halves minus 1 over 6, putting a 0 there, that's con e to the c, and that equals 1 half. So negative 1 over 6 e to the c equals 1 half minus 5 halves is 4 halves, and 4 halves is a negative 2, so e to the c is a 12, which means after all of this work, I figured the amount at any given time is 5 halves minus 1 over 6. I'm going to put a 12 instead of that, e to the negative 3t over 25, or it's going to be 5 halves minus twice e to the negative 3t over 25. And that's going to be the amount of salt at any given time. Then they come in and say, well, now, when will the concentration of salt be 0.03 kilograms per liter? Well, the concentration is 0.03 kilograms per liter. If I multiply that by volume, that will give me the kilograms of salt, which is my y. Well, what's the volume? The volume in this case is 50 liters. If I multiply that by 50 liters, do you notice those cancel out? And I'm going to get 1.5 kilograms. So basically, to reach a concentration of 0.03 kilograms per liter, you're saying, when will there be in the 50 liters of brine 1.5 kilograms? Well, set 1.5 equal to 5 halves minus 1.5 is 3 halves equal that equation. 5 halves minus 2 e to the negative 3t over 25. Subtract this from both sides. That will be 3 halves minus 5 halves is negative 2 halves, which is negative 1. One half equal e to the negative 3t over 25. Natural log of 1 half equal negative 3t over 25. T will equal negative 25 natural log of 1 half divided by 3. And t will be, this was in, what was it? I lost track. Minutes, right? It was given per minutes. So this is going to be how many minutes? And if I get my calculator out, and if I take negative 25 natural log of 1 half, or 0.5, divided by 3, 5.8 minutes. It's going to take 5.8 minutes to reach that concentration. The original concentration is half per 50. The original concentration is 0.01, so you're adding more every minute. It's going to take 5.8 minutes to reach that concentration. Here's another problem. Same idea. A brine solution of salt at a concentration of at a rate of 4 liters per minute into the tank. So let y equal, again, the amount of salt in the mix, in the mixture, that is. So dy dt is going to equal 4 liters per minute. That's the rate of the liquid in. I still have to figure out the concentration. Rate out and concentration. It says initially held 100 liters. The initial volume is 100 liters, and the initial amount of salt, if it has pure water, is 0. There's no salt. You had 100 liters of pure water in this tank, and you started adding a mixture with at a rate of 4 liters per minute. The solution inside the tank is kept well stirred, that's always the case, and flows out at a rate of 3 liters per minute. So let's see how this works. The volume in that initially is 100. I'm letting in 4 liters every 1 minute. I'm letting out 3 liters every 1 minute. So the volume is the initial 100, and since I'm letting 4 in and 3 out, I'm gaining 1 liter every 1 minute. T is in minutes. And if I read on and see what they say if the concentration of the salt in the brine entering is 0.2 kilograms per liter. So basically, what I'm letting in, if I really think about it, just in amounts of salt, I'm letting in 0.8 kilograms of salt every 1 minute. And what am I letting out? Well, what's the concentration? The amount, once you add the new substance, the water is no longer pure. You have Y amount of salt in there, and the volume is 100 plus T. So that's going to be negative 3Y over 100 plus T. Now, this problem is a bit trickier to, maybe I should convert the 0.8, make it 8 over, yeah, it doesn't matter, I could say dy dt, you know what, I'll leave it, it doesn't matter. Since I'm going to use a calculator anyways, makes no difference. So how does this work? This is not separable, so it is a first order though. And if I take the u factor, if I let u equal e to the integral of 3 divided by 100 plus t dt, do you remember? Make sure that's a 1. That is e to the 3 natural log of 100 plus t. That is 100 plus t to the third power. If I multiply this by u, I'm looking at 100 plus t cubed dy dt. If I multiply this by that, that's 3 times 100 plus t squared times y equals 0.8 times 100 plus t cubed. And if I think of this as the product rule, this is 100 plus t cubed times y equaling 0.8 into 100 plus t cubed. If I integrate with respect to t, I'll get 100 plus t cubed times y equals 0.8. Add 1 to the power, divide by that. You could use a u sub, but there's no need. This is really straightforward since this is linear. So I could say y equal 0.2 into 100 plus t to the fourth plus c divided by 100 plus t cubed. Actually, 3 of those cancel with 3 of those, you have 1 left. There it is. I want to figure out what, so first order is to get the equation that tells you what y is, and y of 0 is 0.2 times 100 plus c divided by 100 cubed. 100 cubed is 10 squared, 10 to the 6, and that equals 0. So if I move this over, doesn't that mean that c over 10 to the 6 equal, this is 2 times 10, negative 2 times 10, so c is negative 2 times 10 to the 7. So that means the amount at any given time and let me make sure if I let t equal 0 in there, I'll get a 2, a 0 in there, that's 10 to the 6, 20 minus 20 is 0. Perfect, it does work. Awesome. I got what they want. I always need to figure out the amount of salt in the tank no matter what they ask. They're asking now, when will the concentration reach 0.01? Remember, initially there was nothing. You're adding salt every time. So you want the concentration to be 0.01 kilograms per liter. If I multiply that by volume, that will tell me what the salt is. And what's the volume at any given time? Isn't that the volume 100 plus t? That will tell me the number of, that's what y is. So if I replace this y by 0.01 times 100 plus t equals 0.2 times 100 plus t. Was it 2 or 0.02? Let me make sure. No, 0.8, that's right. And they want a 0.1, not a 0.01. Okay. I thought the number would be odd. Wow, that's really small. So they want a 0.1, not a 0.01. My mistake, forgive me. Minus 2 times 10 to the 7 divided by 100 plus t cubed. So if I move this over, isn't that negative 0.1 into 100 plus t equal negative 2 times 10 to the 7 over 100 plus t cubed? That becomes a positive. I don't like that color, I'm going to go darker. And if I cross multiply, 0.1 times 100 plus t to the 4th equal 2 times 10 to the 7th. And if I divide by 0.1. Now I could say that's move that and make that 10 to the 8 if I want. I don't know if I, but you have a calculator, so it doesn't matter. You could leave it like that. And wouldn't you say 100 plus t equal the fourth root of 2 times 10 to the 8? And t will be negative 100 plus the fourth root of 2 times 10 to the 8, which would be, and this was in minutes, hours, what was that? That was in minutes. And let's figure out what that is. And if I take negative 100 plus 2 times 10 raised to the 8th, oops, and raise that to the 1/4. (18.92 minutes). It's going to take 18.92 minutes. And there is your homework.